Hello everyone, this is Miss Hanley, and today your learning target is going to be I can solve systems of equations by substitution. You can follow along with your foldable over solving systems of equations. So on that foldable you have substitution, elimination, and the back is graphing. And today we're just going to focus on substitution. So the first problem that you have, is a set of two equations. So really it looks like two problems. But remember from when we graphed that we're finding the solution to these two equations. So we're finding where these two lines would cross. So your first equation is y is equal to 3x minus 5. And your second equation is 8x plus y is equal to a negative 16. So when we're solving systems of equations by substitution, we look for an equation that is solved for a variable. In this case, we see that y is already solved and y is equal to 3x minus 5. Well, if we already have one of our equations solved for a variable, meaning x or y is isolated, we can jump to step 2. And step 2 would be to substitute the expression that we have, the 3x minus 5, into our second equation, and that's going to replace the variable that we solved for. So we're going to take our second equation, we're taking out the y, and we're replacing it with 3x minus 5. So I'm going to rewrite my second equation so that we can clearly see what's happening. So we have 8x plus, now instead of the y here, I'm replacing it with 3x minus 5, and that's equal to a negative 16. Now it's just solving an equation as you normally would. So combine like terms on the same side. 8x plus 3x gives me 11x minus 5 is equal to a negative 16. Adding 5 to both sides to isolate my variable. So 11x is equal to negative 11, or x is equal to negative 1. Now if you recall, when we're actually solving systems of equations, we're looking for an entire point, not just an x. So I need the fact that x is equal to negative 1, but I want to actually find what y is and x at the same time. So that full point where those two lines are crossing. So remember that x is equal to negative 1. And let's go back and see if we can find our y value. Alright, so looking at my original equation here, I have y is equal to 3x minus 5. And I know x is equal to negative 1. So just as we did before, since this is called substitution, we're going to take what x is equal to, so that negative 1, and we're replacing x in our first equation. It doesn't matter which equation you substitute x back into, you should get the same value no matter which equation you pick, because this point is the same for both equations. So here we just have y is equal to 3 times negative 1 minus 5, and 3 times negative 1 is negative 3, minus 5, which gives me negative 8. So the actual point where these two lines would cross is the point negative 1, negative 8. And because we came up with one point, we say that we would have one solution. So this graph would be consistent and independent. So next, we want to look at the middle column. You have the equations y is equal to negative 3x plus 10, and we have 6x plus 2y is equal to 20. So again, we're thinking substitution, and let's walk through our steps. Our first step is to say, do I have an equation that is solved for a variable? In my case, again, y is solved for, and it's equal to negative 3x plus 10. So this expression here, we're going to substitute that in, and we're substituting it in for y in the second equation because that is the variable I solved for. So I'm going to replace my y value with negative 3x plus 10. So let's go ahead and do that. So we're down to step 2 already. We have 6x plus, now the tricky part here is we can't get rid of that entire term, 2y. We're only replacing y, so we're going to keep the 2, and because if you see 2y, that's multiplication, we want to show we're multiplying negative 3x plus 10. And when we're multiplying by a sum, we need parentheses. So I'm going to put that in parentheses, and it's all still equal to 20. So as you can see, the only thing I changed was the fact that there was a y there. Well, now if you recall, if there's a number outside of parentheses, we are distributing. So bring down your 6x, and then we have 2 times negative 3, which is a negative 6x, and a 2 times 10, which is 20, and that is equal to 20 still. Combining like terms on the same side, we have 6x minus 6x. Well, that's going to give me 0x, or just 0. So those two are canceling out, so we're just left with 20 is equal to 20. So you might be saying, uh-oh, what happened here? I lost all of my variables. How could I get a point if I have no variables left? Well, if you think about what situation we're in, we don't necessarily have to have lines that cross in one spot. And when I look at 20 equals 20, I'd say, yeah, that's a true statement. So if it's true, we would have infinite solutions, which means that our lines would be consistent and dependent. So when that situation happens, your two lines would be exactly the same line. So if you were graphing this, we would have negative 3x plus 10. So we'll just sort of eyeball this. And the second line is exactly the same. So if they're entirely overlapping, all of those points along this line are solutions to both equations, meaning that they make both equations true at the same time. The third example that we have here is x plus y is equal to 4, and we have 2x plus 2y is equal to 7. Well, back to our first step, we look at solving an equation for a variable, and I don't have either of these equations that are solved for an x or a y. So I want to do that, and I always look for the simplest one. You don't want to make life harder for yourself. So I would take the first equation that we have because there's no coefficient for x and y, so I won't have to divide anything. Since we solved the other two for y, let's solve this one for x. So if I'm isolating x, I need to subtract y from both sides. So I get x is equal to 4 minus y. Well, now that I have a variable that's solved for, I have x equals, I'm taking my 4 minus y, and I'm replacing x with that. So we're substituting for our second step. We have 2 times 4 minus y plus 2y is equal to 7. Continuing to solve, we have to distribute, so we get 8 minus 2y plus 2y is equal to 7. And I want to stress, guys, that it doesn't matter which equation you solve for the variable. If we had solved that second one and we were substituting into the first, you would still come out with the exact same answer. So when we get to this point, I'm saying, okay, negative 2y plus 2y, those two are the same except for their opposite signs. So that means they're canceling out again. So we're just left with 8 is equal to 7. Well, is 8 actually equal to 7? No. Hopefully we're all on the same page about that. So if that's a false statement, this is when you have no solution. And no solution graphs, well, if there's absolutely no solution to two lines, that means that they're never crossing. They're never going to intersect. And what do two lines look like when they never intersect? They are parallel lines. So they're going at a constant rate, and they have the same slope, and they're always the same distance apart. My lines aren't perfect, but you can imagine. Here, actually. There, those are better. So you can see that as long as they're the same distance apart, they're never going to overlap, they're never going to intersect, meaning there's no way to get a point out of that for a solution. So those are the three different types of situations you can encounter, and all of those were solved using substitution.